Single period and probabilities. We're now going to discuss page 36 and 37 in the Simchi-Levi supply chain book. We're going to look at profit, risk, and loss, and we're going to start from the very basic, simple sample of flipping a coin. Now, if you're flipping a coin 10 times, what is the chance of winning? Most likely, you're going to win 1 time out of 2. So that means if you're flipping 10 times, you're very likely to win 5 times. So if you're betting $1 on the flipping, that means you will lose $1 if you lose the flip. You will win $2 if you win the flip. So how much are you expected to win or lose if you flip a coin 10 times? If we just put up the 10 flips, we will have a 50% chance in each of the flips. We said we have a $2 win if we win the flip, and winning the flip is 50%. So that means that what we can expect from each flip, if we do the probability, is an expected profit of 1, because we have a 50% chance in each of the flips. That means that we can calculate that the expected outcome of each of the flips is 1, because it's half of the expected profit that we will get in half of the times. So in total, we will have a cost for each flip of 10. We are expecting to win 10 in total, because we will most likely win 5 flips and lose 5 flips. So the profit will be cost 10 minus revenue 10, 0. So this is a very simple sample. Let's do a bit more complicated sample. Imagine that we're selling ice cream. Now, selling ice cream is weather dependent. So if the weather is good, we will sell 14,000 ice creams. We know that there is a 30% chance of the weather being good on a certain day. If the weather is okay, we will sell 10,000 ice cream, and we believe that to have a 40% chance. And if the weather is bad, not that many people will buy ice creams, and we're only selling 6,000, and the probability for that is 30%. So we have 3 different sales scenarios: 6, 10, and 14,000. So how many ice creams are we going to produce? Well, we have some different options. First, we need to always have the highest and the lowest. And so basically we always want to produce quantities matching the sales quantities. So assume that we can have 5 different production scenarios: 6,000, 8,000, 10,000, 12,000, and 14,000. Now, what is the expected profit on any of these given production quantities? We have 30% chance of 6,000, 40% of 10,000, and 14,000 is a 30% chance. So let's switch to Excel and have a look at it. So first of all, if we're selling 6,000 ice creams and we produce 6,000, that means that we actually sold all the ice creams that we produced. We produced 6,000, we sold 6,000. So we have a profit on each ice cream, because we're assuming that the selling price is 10 and the cost per unit is 7. And we're assuming that all ice cream which wasn't sold at regular price, at the end of the day we have to sell it at half price, 5. So here, if the sales is 6,000 and we produce 6,000, that means that we have 3 on profit on each ice cream. So the profit here will be 6,000 times 3, 18,000. If we do the maximum quantity, which is 14,000, if we produce 14,000 but we only sell 6,000, that means that we have a production cost of 7 for each of the 14,000 ice cream. That gives us a production cost of 98,000. We sold 6,000 at the regular selling price, which is 10 crowns. So we're selling 6,000 times 10. The regular sales are 60,000. That's our first revenue. Then we will get the salvage value for the remaining ice creams, the ones that we didn't sell according to demand. And the salvage value will be, we produced 14,000, we sold 6,000 at the regular price, so we will have 8,000 remaining. So these 8,000, they are sold at the salvage value, which is 5. So they are sold in total for 8,000 times 5, they are sold for 40,000. So the total profit will be 2, because 60,000 plus 40,000, 60,000 for the regular sales, 40,000 for the salvage. That's the money that comes to us, so we get 100,000, but we have a cost of 98,000. Now, we do this for all the different options. So we calculate for the production quantity 6,000, then we will have the same profit, of course, regardless of demand, because we cannot meet a higher demand than 6,000 if we only produce 6,000. Now, what we will do then is actually have a look at what is the expected profit here. The expected profit, if we compare with flipping the coin, when we flipped the coin, we knew that we had a 50% chance of winning. And the 50% of 2 was 1. Now we apply the same thinking here to calculate here. So what we do is, if the profit for the production quantity 10,000, if we only sell 6,000 at a regular price, then the profit will be 10,000. The likelihood of the 10,000 profit is 30%. So we multiply 10,000 by 0.3. We multiply 250,000, which is the expected profit if we sell. It's the profit if we sell 10,000 and we produce 10,000. And we will have the same profit if the demand is 14,000, but we only produce 10, so we only sell 10 at regular price. So multiplying these, we get 178,000 as the total expected profit if we produce 10,000. Of course, the profit can be, if we're unlucky, only 10,000. But it can, if we're lucky, it can be 250,000 for this production quantity. That means that what we're doing is taking the probability here, just as we did with the flipping the coin. So we're assuming that out of 100 days, 30 days would be like this, 40 days like this, and 30 days like this. And that way we can come up with an expected profit. So if you want to learn more about this, this is actually called the news vendor or newsboy problem, and there are several different videos on YouTube that explains the news vendor problem. I recommend one by Piyush Shah. Good luck. Hope this was helpful.